experimental investigation of substitute materials for fine aggregate. Myself Chetanji Konapure, Assistant Professor, Department of Civil Engineering, Walchand Institute of Technology, Solapur. So these are the learning outcomes for the students. So at the end of this session, students will be able to compare the results of the investigation with the specification for fine aggregate, and students will be able to decide the acceptance of substitute material as fine aggregate. Okay, now the first table itself is giving you Sieve analysis of the sample quarry rock dust. Actually, in the first video of the specification for the fine aggregate, different alternative materials were suggested, and the first alternative is the quarry rock dust. Now, the complete sieve analysis table is presented here, and these are the sieve sizes, and this is the percentage passing. Now, this in the sieve analysis, this encircled portion is the 4th and 5th serial number, in which sieve size is 1.18 mm and 600 micron. Percentage passing for that is 19.35, and for 600 micron it is 8.88. So which is the problematic issue for this quarry rock dust for 1.18 mm and 600 micron? Now this is the graphical presentation of for percentage passing for quarry rock dust. For pan 150 micron, 300, 600 it's very, for up to 300 is very low. From 600, 1.18 and 2.36 it is lifted. So this is the nature of graph for percentage passing with different aperture sizes. Now second sample is the marble powder. Now what is marble powder? Let us see this source. The marble sludge was obtained in wet form as an industrial byproduct formed during sawing, shaping and polishing of the marble in factories of Solapur region. And this is the location from which the photograph is taken, that is Sieve on the stone MIDC Akkalkot Road. So as if you observe this marble powder, which is after sawing, shaping and polishing is remained. Now the sieve analysis of this marble powder is also carried out, and the percentage passings are shown here. For up to from 10 to 1.18, the percentage passing is very high, 100 to 70 mm, 77. For 600 micron it is 41, and for if you go for 300, 150 microns, the values are very less. And let us see the graph. The graph for 150 micron, 300, 600 is little lifted. From 1.18 to 2.36, the straight line is there. So it is lifted it here. And this is the nature of the graph for marble powder and the granules, percentage passing. Now, different quarry rock dust samples are taken. 3 samples of quarry rock dust, 1 sample of marble powder, and these percentage passing of these 4 samples are compared to each other. Zone 2 is now considered as ideal. This is lower limit per percentage passing, upper limit percentage passing is shown here. In this percentage passing, in quarry rock dust 3 samples, 4.75, okay, near about 94 to 99, 2.36, 87, 92. Now if you consider quarry rock dust 3 sample, so 2.36 mm particles are very less, 27. So the results for these alternative materials are very random. Now in case of marble powder, 4.75 and 2.36, okay, it is in the proportion to 96 and 91. Now for 1.18 mm size, if you observe, first sample of quarry rock dust, second, third. So a lot of variation is 5 to 19 or 19 to 59 again. So this is very, very large variation. So that is the problem with the alternative materials. And if you consider the marble powder MP, the 1.18 percent passing is 77. So actual zone 2 limit is 55 to 90. So only this marble powder is passing the criteria. Others are not passing the criteria. And major problem is with 1.18 and 600 microns always. Now in case of 600 micron, if you observe Cory rock dust 2, okay, it is passing the criteria. Marble powder, it is also passing the criteria. The problematic issue is there is value which are shown in the red. These are the problematic issue or highlighted for comparison purpose. Now the particle size distribution is the important test, or Sieve analysis is the important test. So the percentage passing for all samples of Bhima river we are observed, and one separate video was created for these tests. 25 samples of Bhima rivers were collected and percentage passings were calculated, and majority of the samples or sources provides that the sand belongs to Bhima river is zone 1. And for the Nanani village, the Na2 or second sample of Nanani village is which represents zone 1, and it is used for further discussion. Now for further discussion of comparison of the different materials, substitute material and the river sand, the Nanani sand is taken and the Cory rock dust, marble powder, the crust sand, all these things samples are compared. Okay, now again once again I am just showing you the grading of fine aggregates as per IS 383. These are the 4 zones. Okay, so percentage passing you are observing from last 2 videos also. Now this is river sand. Now river sand of Nanani village. So the percentage passing of the river sand it fits here, just upper limit of zone 1. So it is sometimes it is very coarser than zone 1 also, river sand of Nanani village. And the Cory rock dust. So it is some various times very fine material, and that fine material is more finer than the zone 4. So river sand is on coarser side, dust is on this side. This is the variation of result for these 2 materials. Now you can see what will be the problem in the concrete. So this is the coarser zone, this is the finer zone. Dust is finer, river sand is coarser, and we are comparing the material, substitute material with respect to the river sand. So this is the problem actually. Okay, now table 4 is the Sieve analysis of the crushed sand. Now there are 6 samples of the crushed sands are collected from the different crushers, and the Sieve analysis is carried out. And after carrying out the Sieve analysis, you can see here the sample 1, 2, 3, 4, 6, 5, 6, and the zone 2 is considered as the ideal. Now this is one of the alternative material which nowadays is used in our area for the river sand, because river sand is scarce as well as costly also. Now in this river sand, what are the issues? Let us see. Now 4.75 for all 6 samples, 98 to 100. Okay, it's good. The variation is not that much, and if you compare with the limit, it's also satisfying the criteria of zone 2. 2.36, 62, 50, 53, 63, 54, 46. So variation has started now from this sieve size. So limit is 75 to 100. So I think no value is exactly lying in the limit or range of 75 to 100. 1.18, if now from sample 1 it is 33 to 2.4, third sample 15, fourth sample 17, fifth sample 21, sixth sample 21. But the limit is 55 to 90, and if you compare all these 6 samples values, all 6 samples are not giving the proper size of 1.18 or the proper quantity of 1.18, so which shall lie actually 55 to 90. It is not happening here. That is the problem in the crust sand actually. Next is 600 micron. So if you observe the values for example 1 to 6, all values are having low amount, and the actual zone 2 is 35 to 59. So if you consider the percentage passing from 1.18 to 600 micron, and if you consider this range or the limit of zone 2, major problem is with the particles passing through 1.18 and 600 micron, and because of that the crust sand is not giving homogeneous mix. So the harsh mix which is coming due to use of the crushed sand. That is the reason that the fines which are required from 1.18 and 600 are lacking. And now if you consider this 300 micron, so if you this value is also somewhere it is matching the 13 and somewhere it is 9. So one sample in the first sample and sixth sample is okay, crossing the criteria. But the major problem is 1.18 and 600 micron. 600 micron size is the pure sand. Always the homogeneity and workability of the concrete depends upon the 600 micron sieve size. Okay, so this is the actually comparative study. Next is slag. So two samples I have shown. These slag samples are 4 samples are shown. 4 samples of marble powders are also taken, and these 4 samples are percentage passings are studied, and it is compared with the zone 2. You can see here the percentage passings for the marble powder. Now this last table number 6 is the comparative sieve analysis of all the samples. River sand, it is here. Quarry rock dust 1, 2, 3 samples. Then crushed sand 6 samples. So river sand, quarry rock dust, crushed sand, all these 6 samples are compared. What problem is found? River sand, okay, let us consider this a natural resource material. 1.18 is 47, 600 micron is 19. And if you consider the other materials which are not from the exactly natural sources, which are the crushed sand, quarry rock dust, the values of 1.18 and 600 microns, there is a problem or complexity. So some values are not matching, some values are very low, or some values are very high. So that is the problem of these substitute materials, and that's why the mixes are not becoming that much homogeneous as the sand is used. So this is basic reason which is we found in this problem. These are the references. Thank you.